Imagine, just for a moment, like 72 seconds, a potential whisper from somewhere else brushing past Earth. That was the wow signal.
Yeah, 1977. A brief touch, maybe, and then nothing.
Exactly. It's this incredible cosmic cliffhanger.
Definitely. A really strong, very unusual radio signal. It hinted at something, well, potentially extraordinary, and then silence.
And that's what we're diving into today, the enduring enigma of the wow signal. So August 77, Ohio State University's Big Ear Radio telescope picks up this signal. It's incredibly strong, it's narrowband, and it has features that just scream, well, maybe not scream, but strongly suggest it's something not from Earth.
Right. And our mission here, using the great source material you've provided, is to really unpack this.
Yeah.
We want to get into the discovery itself, how it happened, but also why it was such a big deal.
The signal's unique properties.
Exactly. Its fingerprints, and then all the attempts to explain it away naturally.
And why, decades later, it's still this question mark in SETI, the search for extraterrestrial intelligence.
So where do we begin this story? It's pretty captivating.
It starts with Dr. Jerry Eman. He was actually a volunteer working on the SETI project there at Ohio State.
Okay.
And the instrument itself, the Big Ear telescope, it wasn't your typical radio dish at all.
No, it wasn't. John Krause designed it, right? More like a huge flat area, almost like a football field, with these angled reflectors, the bleachers, or feed horns.
That's it. What was the idea behind that kind of unusual setup?
Well, Krause's design was actually pretty clever for creating a really detailed radio map of the sky on a budget.
Oh, okay.
And remarkably, it was built, fairly cheaply, lots of university staff, volunteers putting in time.
Right.
After it finished its main sky survey around 72, they repurposed it for SETI. And it became the longest-running continuous search for a long time back then.
So it was dedicated to listening for signals like this. And then, August 15th, 1977, something happens.
Yeah, can you set the scene? What was that moment like?
Well, it's 10:16 p.m. Eastern Daylight Time, and Big Ear gets this hit, a signal just completely unlike anything they'd ever detected before.
Louder than anything else.
By far the loudest.
Yeah.
A huge spike. And it had these characteristics that, when Jerry Eman saw the printouts a few days later, really made him stop and look.
Which leads us to the famous printout, the 6EQ-UJ5 sequence.
Yeah.
The bit he circled and famously wrote, wow, next to. It looks cryptic, but it wasn't actually a message itself, was it?
No, not a message in that sense. It was the computer's way of showing the signal's intensity over those 72 seconds it was in the beam.
Okay, how did that scale work?
So numbers 1 through 9 meant the signal was 1 to 9 standard deviations above the background noise. Pretty standard stuff.
Right.
But once it went above 9, they used letters. A was 10 to 11 standard deviations, B was 11 to 12, all the way up.
And the U in that sequence?
That was the peak.
Yeah.
U represented 30 to 31 standard deviations above the background noise. Just huge. Unprecedented for Big Ear.
Wow.
Literally. And that piece of paper, the printout, with his wow note, it's actually preserved. The Ohio History Connection has it.
Amazing. So that single word captures this record-breaking intensity. But it wasn't just strong, right? What else made it stand out to SETI researchers?
Well, first off, it was narrowband,
Meaning
it was concentrated in a very, very tight frequency range.
Yeah.
Less than 10 kilohertz wide. That's tiny, like maybe 1% fractional bandwidth. Why is that significant for SETI?
That's absolutely crucial. Natural cosmic sources, things like stars or gas clouds, they tend to broadcast noise across a really wide range of frequencies, kind of like radio static, A narrowband signal is different. It's like tuning into a specific radio station. It suggests something focused, maybe something engineered. That's why SETI searches often look specifically for these narrow signals. It could be a sign of technology.
Okay, that makes sense, like a deliberate broadcast, not just cosmic noise.
Exactly.
And then there was the frequency itself. It was hovering around a really interesting number.
Yeah, Krause first noted it around 420.3556 megahertz. Eman later refined it slightly to 420.4556 megahertz, plus or minus a tiny bit.
And that's incredibly close to
100 and 420.4058 megahertz.
the hydrogen line frequency.
The 21 centimeter line. Remind us why that particular frequency is so important cosmically.
Well, hydrogen is the most common element in the universe, right?
Yeah.
And it naturally emits radio waves at this very precise frequency.
Okay.
So the thinking in SETI circles is, well, maybe any advanced civilization out there would know about this fundamental frequency.
Like a universal constant.
Exactly. It could be
Yeah.
a logical place to, listen for signals or maybe even to send them sort of cosmic meeting point on the radio
A
dial.
natural channel.
Potentially. And the slight difference between the, signal's frequency and the exact hydrogen line. Some have speculated that could be a Doppler shift.
Meaning the source was moving.
Yeah, maybe moving towards Earth at roughly 10 kilometers per second.
Yeah.
Blue shift. Okay, so we've got narrowband signal, potentially artificial, right near the hydrogen line, possibly deliberate frequency, incredibly strong. What else?
The duration and the profile. This is key.
Right, the 72 seconds.
Yes. Because of how Big Ear was built and how the Earth rotates, any single spot in the sky passed through its detection beam for exactly 72 seconds.
Okay.
Now, if you had a continuous signal coming from far away, like an alien beacon, you'd expect to see its intensity gradually rise as it entered the beam, peak in the middle, and then gradually fall as it moved out.
And the signal did that.
Perfectly. The 6UUJ5 sequence shows exactly that pattern. Rises, peaks at you, then falls off over the 72 seconds.
Wow.
But here's the kicker. It was only seen once.
Just that one 72-second transit.
Exactly.
Yeah.
Iman and others looked immediately afterwards and countless times since, pointing telescopes at the same spot, and nothing. It's never been detected again.
That single detection is just baffling.
It really is. It fits the profile of an ET signal in transit, but then it just vanishes.
So obviously the first reaction isn't, it's aliens.
Yeah.
Scientists immediately try to find a natural cause. What did they look at first?
Oh, absolutely. Terrestrial interference was top of the list. Could it be some stray radio signal from Earth?
But Big Ear was designed to block that out, wasn't it?
Largely, yes. It had shielding. And the signal's characteristics, very narrow, very strong, right near that protected hydrogen line frequency, didn't really match typical Earth-based interference patterns.
Okay. What about stuff in space, like satellites or space junk reflecting a signal?
That was considered too. But for a reflection to create that specific signal profile, strong, narrow, lasting exactly 72 seconds with that rise and fall, you'd need a really specific type of reflector in precisely the right place at the right time. It seemed statistically very unlikely.
Okay, so simple interference or reflections seemed improbable. What about more exotic natural stuff?
Over the years, people have proposed various things. There was a theory in 2017 by Antonio Paris suggesting it might have come from hydrogen clouds around a couple of comets, 266 P. Christensen and 335 P. Gibbs.
Comets. How would that work?
Well, the idea was maybe hydrogen gas from the comets emitted at that frequency, but that theory got shot down pretty quickly by most astronomers, including the original Big Ear team.
Why? What was wrong with it?
A few things. First, the comets just weren't in the telescope's beam at the right time. The timing was off. Second, comets generally don't emit strongly or narrowly at 1420 megahertz. It's not really what they do.
Okay.
And crucially, the comet theory couldn't explain why the signal was only picked up by one of Big Ear's two feed horns. That's a really important constraint.
Right, the two beams. I forgot about that.
Yeah.
So if it was a comet, both should have seen it just a few minutes apart.
Exactly. But only one did. That makes a simple source like a comet cloud much harder to justify.
Okay. Any other natural ideas? You mentioned a very recent one.
Yeah, just August 2024, a preprint from the Planetary Habitability Laboratory. They proposed a sort of rare astrophysical event, maybe stellar emissions hitting a cold hydrogen cloud in just the right way to energize it and make it emit like that.
Interesting, but still very new.
Very new, yeah. It's still being looked at, needs peer review and scrutiny. It's another attempt to find some kind of natural, if unusual, explanation.
And didn't Aitman himself, years ago, wonder if it could be an Earth signal bouncing off of something?
He did. Back in '94, he floated that idea, a reflection off space debris, maybe? But he later reevaluated it.
And decided.
He concluded the requirements for such a reflection, the object size, reflectivity, precise orbit to match the signal profile, were just too specific, too improbable. So he kind of walked that back.
Plus that frequency, 1420 megahertz, it's supposed to be a quiet zone, right? Protected for radio astronomy.
That's right. International agreements reserve that band to keep it free from human-made transmissions. Now, that doesn't mean interference never happens. There have been documented cases.
Sure.
But again, the specific fingerprint of the, signal made garden variety interference seem less likely to most investigators.
So we've gone through a lot of natural possibilities, and none seem to quite fit perfectly. Which brings us back to the really exciting, if speculative, idea.
The extraterrestrial hypothesis.
Yeah.
And look, the reason it persists, the reason we're still talking about it, is because those properties we discussed, they line up remarkably well with what you might expect from an intentional artificial signal.
Narrowband.
Yep.
Near the hydrogen line.
A potential beacon frequency.
Super strong.
Way above the background noise.
And that perfect 72-second rise and fall profile.
Matching a distant source, moving through the beam, it ticks a lot of boxes for a potential ET signal candidate, even though it's just this one unconfirmed data point.
If it was artificial, I mean, the implications are just staggering.
Oh, completely. It instantly makes you think about the Drake equation, trying to estimate how many civilizations might be out there.
And the Fermi paradox, if they are out there, where is everybody?
Exactly. Wow. Signal acts like this single tantalizing clue that maybe, just maybe, someone is out there, but it doesn't resolve the paradox. It almost deepens it.
So where did this potential cosmic hello come from? Which part of the sky?
It came from the direction of the constellation Sagittarius, near a star group called Xi Sagittarii.
Okay.
More specifically, about 2.5 degrees south of the star Xi Sagittarii itself, and about 3.5 degrees south of the ecliptic plane, the path the planets follow.
But there was some uncertainty because of the telescope's design.
Right, those two feed horns again. Because they weren't sure which horn detected it first, it gives you two possible narrow strips of sky for the origin point, slightly offset in right ascension.
So not one spot, but two possibilities.
Two narrow strips, yeah. In galactic coordinates, that's around longitude 11.7 to 11.9 degrees, latitude minus 18.9 to minus 19.5 degrees, roughly.
And were there any likely stars in those strips? Sun-like stars, perhaps?
Well, back in 77, not really. No nearby sun-like stars matched those coordinates.
But that changed.
Yes, much later, with better sky surveys. By 2022, astronomers had identified 3 potential sun-like stars that actually fall within those possible origin strips.
Oh, interesting. Any stand out?
One is better characterized than the others. It's called 2MAS 192819822640123. Bit of a mouthful.
Catchy. How far away?
Estimated to be about 1,800 light years away, which sounds far, but galactically speaking, it's not that distant.
And finding these candidate stars must have triggered more follow-up searches.
It did. The Breakthrough Listen project, which is a huge SETI initiative, targeted that specific star and the surrounding region in May 2022.
Using big telescopes?
Yep, the Green Bank Telescope and the Allen Telescope Array. They spent a good amount of time listening very carefully.
And the result?
Nothing. No signals detected that looked like technosignatures, nothing artificial. The silence continues, at least for now.
Huh. So even focusing on potential suspects yields nothing. It really highlights the mystery. And it's fascinating that Jerry Amon, the guy who found it, still seemed pretty convinced it could be the real deal.
He really did. I remember reading a 2019 interview where he said, quote, he's convinced that the WOW signal certainly has the potential of being the first signal from extraterrestrial intelligence.
That's quite a statement from the discoverer.
It really is. It shows how compelling those initial characteristics were.
What about trying to catch it again, right after it happened? Did Amon try?
Oh, yeah, immediately. In the days and months after August 77, he used Big Ear to re-observe those coordinates whenever they came around again due to Earth's rotation.
Looking for that second hit from the other feed horn.
Exactly. If it was a steady beacon, it should have appeared in one horn, then about 3 minutes later in the other. But it never did. Not then, not later.
And others tried too, with different telescopes.
Many times. Robert Gray did extensive searches with the Meta Array and even the Very Large Array. H. Paul Schuch from the SETI League looked too. Always null results. Nothing.
Just that one time. It's like a cosmic phone call where someone hung up before you could answer.
It's a good analogy.
Though didn't we kind of try to call back? Symbolically, at least?
Yes, sort of. In 2012, for the 35th anniversary, the Arecibo telescope before its collapse, sadly, they beamed a message towards that region of space, specifically towards 3 stars in the general direction.
What did they send?
It was part of a National Geographic Channel thing. They collected about 10,000 Twitter messages.
Twitter messages? Seriously?
Seriously. They bundled them up with a repeating header signal, so if anyone picked it up, they'd know it was deliberate.
Wow. A Twitter message replied to the WOW signal. That's something.
It's a very human thing to do, isn't it? A message in a bottle tossed towards a whisper from decades ago. Poignant, even if the chances of a reply are, well, astronomical.
Absolutely. It shows how much this event captured our imagination.
It really does. That desire to know if we're alone.
So let's wrap this up. We have this signal. Incredibly strong, narrowband, right near the hydrogen frequency. Perfect profile for a distant source transiting the telescope beam.
Check.
But detected only once.
Yeah.
Ever, despite tons of searching.
Right.
And while there are natural explanations proposed, none have really stuck. None perfectly explain all the features, especially the single-horn detection.
Precisely. That's the... Wow. Signal in a nutshell. An unsolved, tantalizing puzzle in the history of SETI. It's arguably captured the public imagination even more than the scientific community sometimes, you know. Often held up as the best evidence we have, even though it's unconfirmed.
So the question has to go to you, listening right now.
Mm.
We've walked through the discovery, the signal's weird properties, the attempts to explain it naturally or otherwise, the searches. What do you think? What's your gut feeling?
Yeah, is it that fleeting message from ET, or is it some super rare, maybe totally unknown natural glitch in the cosmos that we just haven't figured out yet?
It's a question that keeps people talking, keeps people searching.
It really does. Maybe, like the astronomer Seth Shostak once put it, it's like hearing chains rattle once in the attic. You hear it, it's weird, it's unexplained, and it just leaves you wondering long after it's gone.
Well, thank you for joining us on this deep dive into the, wow, signal's enduring mystery. We might have the answer.
Not yet, anyway.
But just exploring these kinds of puzzles pushes our understanding, doesn't it? It opens up the possibilities of what's out there.
Definitely. And we hope you'll keep exploring, too. Check out the sources. Maybe look into things like the Drake equation, the Fermi paradox, what SETI is up to today.
And maybe the real point of it, wow, signal isn't what it was, but the questions it keeps asking us. Questions about our place in this huge universe and whether maybe, just maybe, we're not the only ones asking.